Thank you very much for joining today. After I think around two months back, now we are joining back. Uh, so today we are going to have a small discussion on monitoring equipment in energy management. In last sessions, we were discussing of several type of uh, machineries, processes, which help to economize the energy management. For example, we were discussing on last sessions. I'll give you in brief. We have discussed lighting systems, heat transfer, compressor and compressed air systems, pumps. These things are all processes. Now, what we need is to monitor those process. We need to measure because, for instance, lighting systems or heat transfer, we need to have energy to produce the heat, but in the meantime, we need to control the heat generation, or we need to reduce the waste heat generation with this type of process. To support these monitor the control systems, we need to have monitoring equipment. So today we are going to discuss on this type of monitoring equipment, and we will roughly go into deep that how those equipment perform while we are getting into those processes. So these are the type of monitoring we need to have. Electrical measuring instruments, combustion analyzers, manometers, thermometers, water flow meters, speed measurement, leak detectors, lux meters. These are type of monitoring we used to have. I'll give an example. A couple of months, I designed a dryer. It's called a cashew nut dryer. It's help to dry the cashew nuts. I designed a chamber, small chamber, and put a box shape. I designed a box shape chamber like this, and covered all the area, all the walls, and put a heater inside of that. So the inside the temperature shall be maintained up to 70 degrees. So I put a heater, and to maintain that this temperature, what shall we do? I used another temperature controller. From this, what we can do is, when the inside of the temperature increasing up to 70 degrees, the temperature controller give automatically signal to control systems to stop the heater, right? So this automatically control system help to avoid this manual controls. Normally what we do is we can measure the temperature manually of the heater, but it will be a bit of fatigue, that another human should intervene with this, so that automatical controller will help to avoid the additional man hours, manpower use on that, and the accuracy of the system. And this will help to reduce the heat wastages as well. So these are the type of techniques we can use. So now let's move on to The next, have you ever used any system like this? Can you just tell, have you used this type of control systems in your day-to-day life, or have you seen this type of equipment? Can you give a brief? Can you explain some equipment you have used? So, if can anyone say what type of monitoring equipment we can use? For example, it's a temperature controller, or in a greenhouse, we need to control what? We need to control the humidity inside of the greenhouse, so that we need to have a humidity controller. Then pressure, the water flow control, and in your water tank, there will be a water level controller that will be automatically off when the water going to spill out. So why do we need them? The purpose of requiring of this type of monitoring equipment, why we need them? We need to control the system, right? We need to avoid the wastages happen, and we need to have a accurate uh, settings environment inside of a chamber or whatever. Can we do without them? Sometimes, yes, we can use without them, but going into manual operations, it will be a bit hard. The accuracy will be not 100% sure that due to these manual operations, and it will have additional cost, deputing another manpower or whatever. So that if we put some automated or automatical control systems, the accuracy will be increased, and ultimately that we can save the energy, give a good output, and the total system will be improved. What properties should they possess? So we will discuss in later around slides. What do they do? Measure electrical parameters: kilowatt hour, kilovolt hour, kilowatt, power factor, hertz, kVAR, amps, volts, harmonics. And we have a handheld meters, instant measurement. For instance, when you are going into any type of a shop or institution, now that all the people are, that the security guy will put on to a face. What is that? That is that temperature meter to measure the body temperature of you. So those are the handheld meters. And even in highways, that traffic police are measuring the speed of vehicles. So those are the handheld instrument we used. And some advanced features are there to get the printouts or periodically get the data, and we can put into the system, so you can get the data onto our computer, or we can upload into the internet, so that anywhere in the world we can see how our process is going on. So these are the advanced facilities inbuilt with these latest technologies of measuring equipments. For electrical measuring equipment, what they do, So this unit is a type of a meter that measures voltage, current, and current peak, effective reactive power, power factor, phase angle, frequency. Those details for electrical engineer or electrical technicians, these type of parameters are needed to design their systems and to check that the design system is running up to the required level. So this equipment is applied to measure the various electrical parameters. How we use this equipment? There are some 2 crocodile clips, 3 crocodile lips, red, yellow, and black. Those are used to measure the voltage in naked wires. We can fix these clamps onto naked wires to measure the voltage. And this clamp used to measure the current of a wire. So we don't need to make it naked, that the wire is not necessary to be opened, but even with the insulated wire, we can clamp this. We can clamp that wire into these openings, and we can measure the current. Only the combination of clamps and crocodile clips give other measurement as well: power, power factor, frequency, and all details. Measurement are taken at the where we can get this measurement. This can be used in the junction box, where that all the circuit board and other control switches are there, or we can use that wire line as well to measure the current. So this will use to check the measure of current. How we use this? Say this is a power supply side and this is a load side. So for example, this will be a electrical bulb or a motor or whatever, and this is the source of supply. We can put the live wire inside of these openings from the clamp sensor. So anyway, what are the color codings of electrical systems? We have brown, blue, and green. The wire codings are, there are 2 types of wires. Brown, blue, green. So what is a live wire here? What is a neutral and what is ground? No, blue is
brown live.
Yes, brown is live. Blue is neutral. And green is ground. Ground of earth. So when you get the measurement of current, we can live wire is that brown wire. Brown colored wire, it can be clamped onto this opening so that we can get the current. But if you put, if you don't know the color codings, what is a live wire or what is a neutral wire, you put that clamp onto this neutral wire without knowingly, you are unable to get the readings. So better to have an understanding of this color codings. So when you need to get the voltage, you need to put a red clamp onto the live wire and black and yellow onto the neutral wire. So these color codes are sometimes different. Earlier we told live, neutral, ground, blue, green. Sometimes the live will be red, neutral will be black. So that so you can Google it and check what will be the correct wire accordingly, whether it is a live or neutral. Based on the color coding, you can understand what is that. So here you can the wire should be naked. We need to get the opening. We need to cut off the wire and get the this copper wire, and we can clamp that this crocodile clip onto these naked wires and check the voltage. So that's how we measure the voltage. So when you get the measurement of the three-phase lines, this is the way we can work. So in the three-phase line, we have the three-phase, 1, 2, 3, and this is a ground. So when you want to get the each line current or voltage, you can need to clamp this two clips into ground or neutral, and then other lines, other clip alternatively to line 1, line 2, line 3. Based on that, you can check each line voltage and current.
Okay, USA Corporation introduced power tester model 286-20 from Germany. This is a unit that every people involved in measurement, electricity, and maintenance people should have. It includes a very nice carry-on track, connection cables, sleeves, and for a manual, as well as a main unit 3286-3 on Thermometer. This unit can measure voltage, current, minimum, maximum values, as well as power factor, active, reactive, current, power, phase detection, voltage and current peak values, frequency, harmonics up to the cranium, voltage and current, total harmonic distortion, phase angle, reactive factor, and other characteristics. It has an optical output to connect directly to a PC. Everything mentioned before is to make one-phase and three-phase sound circuit measure. But these are many reasons more, that's why you have to acquire a Uncontact Thermometer circuit 2286-2. Okay, USA Corporation, thanks for your time.
Hope you saw the video, and let me know that the audio is, can you hear the audio of that video? Oh, I think there is a problem with this mic, or let me check. Wait a bit. Okay, now let's move to that precautions. So when we are fixing these clamps or getting the readings of this type of equipment, the voltage is 220 and in three-phase lines, there may be around 330 voltage. So there's a risk of electrical shockages happen or whatever the safety hazards are there while doing that. And it may, if you attach the clamps in a wrong scenario, that there may be some possibility to damage the equipment as well. So the precautions are never attach a clamp to a circuit operating maximum rated voltage or over bare conductors. Connect clamp or probe to the secondary side of a breaker or fuse. Use rubber hand gloves, boots and safety helmets to avoid electrical shocks. Consult the operation manual before using the equipment. So every equipment, there is a particular manual that that shows the how the equipment to be operated and what are the precautions to be done before start the equipment and while continuing the operations with that equipment. And there are some instances where it include that maintenance, how it can be maintained and how to get the measurement or whatever with that equipment. So better before get any operations or get the testing of the machine, try to use this operation manual so that you will have a clear view how it to be operated and how to get the readings out of that one. So here it is mentions connect the clamp on probe to the secondary side of a breaker. So what is the secondary side of a breaker? So this is the main breaker. It is called primary breaker. And we have dividers. And here we have the secondary stations. Try to get the readings from this secondary space. So that will be it will help to reduce this electrical shockages and other safety hazard, and also you can have a better reading as well. Then we move to combustion analyzer. Previously we used electrical measurement, how we measure the electricity in terms of current, voltage, power factor, kilowatt hours, wattages, whatever. Here we use a combustion analyzer. What the combustion is do? Combustion is burning of fuel or whatever the burnable items. So when we burn, there are a lot of substance will be ejected from the burning process, like gases like carbon monoxide, carbon dioxide, nitrogen dioxide, sulfur dioxide, oxygen, and some solid particles like fly ash, soot, and other things. So for a good example is engine, vehicle engine. So annually we are doing the vehicle emission test, right? So that is to measure how much of toxic fuels, toxic substances which will emit from the engine due to this combustion process, right? So to have a good environmental friendly vehicle, we need to reduce those toxic emissions to the environment with this fuel burning in the engine. That's why we need to measure those substances. That is how that combustion analyzer come into play, that to measure those toxic elements. What does it do? Measure the composition of flue gases after combustion in percentage. This will give a percentage. It is 20% of carbon dioxide, nitrogen oxide, like that. It will give a percentage out of a total output. How much of percentage is included this particular each element. Measure the percentage of oxygen or CO2 in flue gases. If one is measured, the other can most often be calculated. That is, if we have a one parameter, so other parameters can be easily calculated with the formulas, because burning is a combustion process. Normally what we get is, if we the fuels are hydrocarbons, when you're burning a hydrocarbon, now what are the emissions? Heat, we can get the heat, then CO2, H2O, and other emissions like these type of emissions. So this is the formula. So if we know the type of hydrocarbon, we can calculate how much amount of CO2 it will emit, how much of H2O it will emit, like that. Combustion efficiency can be calculated with an inbuilt program. So this combustion analysis, we can get the efficiency of this combustion process. So if we burn the process, the whole carbon will be converted into CO2 and water, so that the efficiency will be increased. But in practical scenario, that will be not will happen, because there may be some unburned carbons. Unburned carbon will happen. So in that vehicle emission test, that's what is tested: unburned carbon emissions and the carbon dioxide, the percentage. If we have the unburned carbon, so that the system efficiency will be reduced, because that whole fuel which will burn, there may be some unburned carbon emission as well. So that is a wastage of energy, because unburned carbon means that we could use this carbon as well to generate the energy, but it will be lavishly wasted. So with this combustion analyzer, we can check the combustion efficiency. Where it is used: any equipment where combustion take place, boilers, furnaces, even vehicle engines. Measurements are taken in the duct. Measurements are used to identify efficiency leakages. This is a type of monitoring equipment which we use to measure the combustion. So this is a probe. This probe will be inserted into where the combustion emission happen. in vehicle, we can fix on into that silencer, right? So that particle will be touched on to this surface, and that the automatically reading will be given how much of percentage of unburned carbon, carbon dioxide, and what are the emissions in each elements it's exhausted from the combustion chamber. So this is another analyzer, far-right analyzer. This is a gas analyzer. So here the probe where we put inserted where the exhaust happen, and this is the display. Here you can easily visible. So what is emissions happen, and we can get the printout as well. Spontaneous printout, the performance of the systems, we can check on that. This is for my own old vehicle, so which I got the emission testing. So in hybrid engines, the government is not pushing to get the this type of emission testing because it is a green vehicle. But the other engine type vehicles, we need to have this annual emission testing. So here you can see the parameters, right? The vehicle type is the fuel type is gasoline. Gasoline is a petrol, and so here it's give the idle condition. What will be the emissions? The engine RPM is 1120 to 3. So these are the emissions: CO2, O2, CO2 type of things. And if you accelerate, and what will be the emissions happen? Precautions. Always calibrate the instrument in open fresh air before taking the measurements. Say the calibration is important because we are getting the reading with a reference of another some readings, because the same probe used for 2-3 measurements. So the readings will be deviated because there are some contaminations on the probes with the previous checking up. And if you put that same old probe to the another measurement, we are unable to get the actual readings due to this the previous cloggings happen on this probe. Better to clean up the probe and calibrate the instrument before taking the measurements. Check the clogging of the air filters. Ensure that the rubber tubing carries the gases to the instrument is not bended. Plug the open space of a monitoring hole with cotton rags. Use gloves, goggles, and safety helmets. Consult operating manuals before use. Then we go for manometers. What is a manometer? What does it do? Manometers are widely used instrument in energy audits for measure the differential pressures across 2 points. That is used to measure the pressure difference with 2 points. Say this is the air tube. We need to get the pressures between these 2 points. With these manometers, we can get the pressure difference between these 2 points. Assume that pressure 1 is higher than the pressure 2. So pressure difference is. So this pressure difference can be taken with these manometers, whether it is a positive pressure or negative pressure. So here we have compared to pressure here. Compared to this point, here we have a negative pressure. The liquid column manometer is the oldest type, U-shaped tube half full of liquid. And the liquid we used can be oil, water, or mercury. A barometer is a manometer. Have you ever seen that when you are constructing your house or when you need to level 2 places? Say this is a 1 column in a building. This is another column. Our carpenters are put a water tube. So if we want to get this level on this column as well, same level, what they are putting is a water level. They are filling out water into a water tube and check the both water levels are in the same position, right? That is how they are getting the level. So this is a very accurate reading to check the water level. This is also type of a manometer. What is this is a principle. If the both openings are at the same pressure, the liquid level is at this point. But what happened if say this is A and B? If the pressure at A rises, the liquid level drops down here and come up to this. So this will be the pressure difference. Pressure difference is PA minus PB. This is the pressure difference. How we calculate the pressure difference? H rho G. H is the height. This is the liquid density. This come this is the gravity. So what happened if we vacuum at this point? That means here the pressure will be raised compared to this, so that the height will be dropped down from here. So this will be a negative pressure. Where it is used to measure the pressure difference in air pipes, water pipes, gas pipes of various equipment, mainly compressors, pumps, and draft systems. This is where we can use this type of manometers. And these are the type of manometers we are used in the system. single limb liquid column manometers, flexible membrane, or coil type manometers. Have you ever seen that if in a high pressure tube lines, you can see this type of meter reading? So these are the type of membrane type manometers used to measure the air pressure or liquid pressure. In air compressors as well, these type of meters are there to check the pressure readings. A good example is an air compressor. Have you ever seen an air compressor? So these are air compressors which help to pressurize the water pressurize the air inside of this tank chamber. This pressurized air can be used on various applications. Type of we need to spray paint a wall or vehicle, we need to have this type of compressors. Or if you need to have a pneumatic applications in a automated process like pick and place of that product, right? If you need to actuate a cylinder or type of things, this type of pneumatic applications, we need to have this type of compressed air systems. So these are the type of compressors we used. Here you can see this also type of a manometer used to measure the pressure, right? Here you can see that the pressure is calculated as bars or PSI, right? This compressor helps to build the pressure inside of the chamber, and the pressure will be raised continuously. And if it's come to this red point, this valve automatically open and close these systems, and the compressor will be automatically shut down. So what is the importance of this having of this type of valve and the control system? This type of compressors has a limit. There has a pressure limit. If we exceed that given pressure, the sudden blast will be happen. So that's why we need to have this type of manometers to measure the pressure inside of the chamber, and control systems to automatically cut off and cut on the compressor. So this is what happened if we exceed the pressure inside of the compressor. The sudden blast will happen. That will be a big catastrophic failure, because a lot of people may be injured and equipment will be damaged. So a lot of negative points if we are unable to control the systems. That's why we need to have this type of monitoring and control equipments in the system. How to use a manometer in air pipes and ducts. This is how we can measure the pressure. We can put, this is a manometer, we can put 2 points where the pressure, the flow is coming, we can put here, and other points is other neutral point. So these 2 points are there. So when the pressure is built up, if there is no pressure difference, the level will be at at this level, right? But due to the pressure difference, this level will be height will be increased due to the additional pressure build up in this point, right? So that the liquid level will be increased. So calculating the height, we can measure the height, and from that we can calculate what will be the pressure built inside of this pipe. These are the type of several configurations of how that pressure is measured. There are two openings here. Here there are two openings inside of the pipe. There is another pipe as well, here and here. Right. These are the several type of configurations where we can measure the pressure differences. Here it is given that this is the velocity, speed of velocity of the liquid, gas or water, whatever that we can get this pressure with the Bernoulli equation. What is that? This is the Bernoulli equation. With that, you can calculate the pressure. How to use a manometer? Air pipes and ducts. Turn on, select a measurement unit. Measured value appears on the screen. So whether the measurement unit is type of bar or PSI, bar, PSI, or kilonewton per square meter. So these are type of units. So we can select the unit, particular unit what we want, and get the measurement. How to use a manometer, air pipes and ducts. Bernoulli equations to calculate the velocity. Differential pressure equal square velocity square divided by 2g, where differential pressure is measured at V is the velocity, G is the gravity. So this is the Bernoulli equation, energy per unit volume before and energy per unit volume after. For the Bernoulli equations, all the summation of at this point is equal to all the summation of at this point or at this point, right? So this will be a constant for given any point on a particular pipe or duct system. With that, we can calculate. Here the P1 is a pressure energy. Here is a kinetic energy. Is a potential energy. So we study this these equations at our first lecture. This is how to use a manometer in a water pipe. So is the water is flowing up at these directions, we can put two probes from here and here at a 2 meter distance, so that we can measure the pressure difference in height. This is the pressure difference. Yes, but not clear. Prabodhita, what is not clear to you? If you can't speak, please text me so that I can explain again. So this is how we calculate these differential pressures, right? This is the equation F LV squared over 2GD. So F is the friction factor of a pipe, L the distance between two tappings, V velocity, D diameter, and G gravity. Assume this is a pipe. This is a pipe diameter. F is the friction factor of a pipe. So the wall, the pipe wall, we have a friction factor. Whether it is the smooth wall or rough wall, the friction factor will be different for each pipe. Based on the pipe, the friction factor will be deviated. And V is the velocity of the liquid, G is the gravity, right? So this will be the equations. You just keep in mind, I am not questioning from this. This is for your rough understand how this type of pressure difference could be taken. So that is how it is, this type of equations. So if you want to prove this formula, we need to go into deep on the basics, but I am not going to explain those things. That is not required at this level, because what we need is the type of measuring equipments and how we can calculate it, and how we know to use this type of apparatus. But we are not going into the theories, so that is beyond our subjects, and that is actually not required here. Precautions: do not expose a manometer to very high pressures. Always consult the operating manual before use. So here that the main the precautions is that all the other equipment, as I mentioned, always consult the operating manual before use. So this is very important, right? So the main concern is the safety, the people's safety. So these are high risk activities, high pressure build up in the systems. It causes severe damage into people and other equipment. So that be cautious while getting those readings, and while using those type of instruments. And thermometers. What a thermometer does. Thermometer measures the temperature of any fluid, surface, gas, or even solid bodies. There are two types of thermometers: contact thermometers and non-contact or infrared. Right? What is a non-contact thermometer? These are the non-contact thermometers. So we don't need to go near to the source of the thermal source. We can get the measurement from far away, right? So these are the very popular apparatus which we used in these days. Due to COVID, we are not, there is a 1 meter distance between each us, so that how we could check before you enter a building or supermarkets. A security person is pointing this gun onto your head or hand to get the temperature. It is a non-contact type of measuring apparatus to measure your body temperature or whatever the heat source. And contact types. So these type of items also are used as well. Even we need to get the body temperature. There are some glass tube type of thermometers which can be put into a armpit to get the temperature of your body. So these are contact types and non-contact as well. Where the thermometers are used, measure the temperature of, for example, ambient air, refrigeration plants, including compressors, cooling towers, chilled water air, boilers, surface, flue gases, steam pipes, feed water, condensate water, furnaces to check the temperature of surface, flue gases, cooling water, and waste heat recovery process, gas, water. So even these type of thermometers are there in your day-to-day instruments. For example, iron. Cloth ironing. So we used iron to iron the clothes. We can set the temperatures based on the type of clothes we used, right? So different type of temperatures we can adjust it. Here also we have a type of a thermometer to control the temperature inside of this heated plate, right? So this will be automatically on and off to maintain the temperature at a given particular level. Measuring temperature of air, liquids and gas, generally not used for surfaces. This is a thermocouple, right? A thermocouple is it is a combination of two type of steel. For example, say this is a 1 meter height, 1 meter at the same width and length, right? So this is one. These are two different type of steel, right? If we put this combination, So these two plates are bind together, right? It will be bind together, and we put in elevated temperature area. Say we put into 100 degrees environment, right? So this steel has its material properties. That is a difference with this material property. For example, if we give a heat into a body, it will be expanded, right? So if we give T1 to here, it will be expanded up to x1, right? This steel particle will be expanded, its length up x1, right? But this steel particle is different properties, right? Due to the same temperature at the ambient environment, that will expand x2, right? So these will be expanded in the different lengths. So what happened? But anyway, these are bind together. So what will happen is this combination will be bended. Like this. So this is the initial position. This is the initial position due to the heat variations. Say x1 is higher than the x2. This is x2. This is x1. So it will be bent like this, right? So based on the temperature, if it is have a higher temperature, it will be bent more like this, right? So this is the indicator. So at 100 degrees, the distance is like this, right? If you put 200 degrees, it indicates the bending of up to this point, right? So with that, we can measure the temperature. Suppose if it's bent up to this point, we can estimate that the temperature is 100 degrees, right? This is how the thermocouple works. So this is how to operate a thermocouple. turn on, insert probe, reach temperature on display, wait 2 minutes for stable reading. We need to have some particular period, keep it there to get the readings. Where it is used, any equipment where combustion takes place, boilers, furnace, measurements are taken in duct. Measurements are used to identify the efficiency or leakages. Even we can use this type of temperature systems to measure the temperature of have you ever seen that the compost plant? So this is a compost. So these microorganisms will help to compost these type of dumps, right? So to have a good composting process, we need to maintain the temperature inside of this compost. When this bioorganism digesting this compost, it will generate heat as well, right? We need to maintain this temperature on a particular level. If we exceed that the temperature, what will happen is this microorganism will die, and finally the composting will be not effective. So that we need to check the temperature of this compost plant, and we need to turn it up, turn it down, and mix it to maintain that temperature so that the effective composting process will happen. To check this temperature, we use this type of probe, temperature probe. And this also a type of a thermocouple, where two type of steel particles are bind together, and this probe will measure based on the expansion and contract how the temperature varies inside of this compost storage, right? When you are getting the temperature, we need to keep several times. We keep it for a period to get the terminal temperature, stable temperature, right? We need to wait for some time. Where the non-contact and infrared thermometers is used, measure the temperature of surface only, used for moving object, contaminations, voltage, electromagnetic field, vacuum, large distance heights, too high temperature for thermocouples. So here we can use these type of contact and non-contact thermometers in motors, electrical motors as well, because electrical motors also may be heated up when it is in operation for a particular period. It will heat it up. There is another unit called to check the temperature, and if the temperature is exceeded, the motor will be automatically stopped, and if not, the motor will be burning up and damaged. That's why we use this type of measuring equipments and control systems to safeguard the equipment as well. This is an uncontact infrared thermometer. Here you can see the measurement in the Celsius degrees. We can change a unit, Celsius or Fahrenheit. Here it is given the range as well. The temperature range is minus 50 to 550, right? So when we are selecting this type of measuring equipment, you need to find out their active range. Here it is given -50 to 550 degrees. Suppose your working environment is beyond 550. Say it is the steel manufacturing process. Environment a particular point temperature will be exceeded 1500 degrees. So this unit will be not effective for this purpose, because here the temperature range is given -50 to 550 Celsius, 550 degrees Celsius. Based on the temperature range, we need to save the particular apparatus as well. If not, what happens is even this the measuring equipment also will get damaged due to exceed its temperature. So this is how this measures a temperature in image. This is a temperature image, right? So when we direct our camera, temperature camera onto this heated body, it shows how the temperature varies at different locations. Here it has a high temperature, and this is low temperature. This is a image of a burner, right? So you can see the flame as well, burning flame as well in blue color. If we direct this thermal image camera, this will be visualized. So you can understand where the high temperature is and where the low temperature is. These are the other thermal images we can see. This is in engine or something. So here is a turbine. How the temperature varies. Here and here it is power line systems, high tension power line systems, where the temperature varies is there. Here you can see the belt-driven pulley and the belt-driven motor. So here even this belt and this pulley is a heated bodies, right? This is how we see that. This is how that thermal cameras is. Here it is given the thermal variations. The unit is in Fahrenheit. Given is Fahrenheit. 70.4 here. The lowest temperature is 70.4 Fahrenheit. Highest point is 130 Fahrenheit. What is 130 Fahrenheit? Is it Celsius? This is 54 Celsius. So this is how that thermal imaging is getting. This is thermal image camera. We can direct onto the particular point. Here is that burning area, right? This person is directing his thermal image camera onto this burning area and check that what is the temperature there. Precautions. These are the precautions we can use in thermocouple and infrared. Thermocouple immerse probe in a fluid gas and only read measure after 1 to 2 minutes. Because we need to have the terminal temperature or stable temperature. Note temperature range before you start. Do not touch naked flame with the probe. That will be damaged your skin. Infrared. Set the emissivity for the surface where the temperature is measured. Always consult operation manual before use. Water flow meters. How water flow is measured. So there are 3 basic methods to measure the water flow rate. One is a water flow meter. Is an instrument used to measure the linear, non-linear mass or volumetric flow rate of a liquid or gas. And the choice of method type of water flow meter depends on the site conditions and required measurement accuracy. And another method is a time to fill method. What is allowed to fill a known volume of a vessel or tank in cubic meter? The time taken to fill up the volume is recorded using stopwatch in seconds. The volume divided by the time gives the average flow, that is cubic meters per second. Another method is a float method. This method is generally used to measure the flow in an open channel, especially distance. For example, 25 meters to 50 meters is marked on the side of a channel. A ping pong ball is placed on the water and time takes for the ball to float to mark distance is recorded. Multiple readings are taken to get more accurate time. So that a float type measurement is done like this float method. So this is the water stream. So we keep a particular 2 points. Say the distance is 50 meters. So we put a ping pong ball. If we put a ball and start the stopwatch, time 0. And we measure the time taken to reach this ball up to this point. Right? From this method, you can calculate the water flow. Depending on the flow conditions and the site characteristics, the calculate velocity is further divided by factor. We can add the factor 0.9 or 0.9 to obtain the peak velocity in an open channel. Since the velocity at this surface is reduced due to drag forces, the winds, but this reading will be not accurate because we assume this ball is traveling due to the water flow, but this ball will be impacted with the wind as well if the additional extra wind is there. The ball will be traveled fastly compared to the water velocity. So there are some limitations as well when we are calculating this type of water flow or flow rate. where the water flow is used. Water flow rate is measured to determine the efficiency of pump, cooling towers, refrigeration, AC plant, heat exchangers, condensers. How to operate water flow meters? Water flow meter used to measure the flow in open channel. Turbine flow meters. This is the pipe where the flow direction is there. We insert this unit into this pipe. There's a turbine as well. When the water flows or liquid flows to this direction, the turbine will be automatically rotated at this direction of rotation, the turbine, right? So based on the rotation RPM, number for that how much of rounds per minutes happening, it will be automatically calculated with this motion sensor, right? This is a motion sensor where the turbine blades, how many blades rotated per second, that can be counted with this motion sensor. With that, we can calculate and display the flow velocity on this display. This is a type of flow meter method we can use, which will be fixed inside of a pipe tube. And this is a paddle wheel method. So this is an impeller that will be fixed onto this flow stream, right? So when the flow is there from here to there, the impeller will be rotated, will rotate automatically due to this water flow, right? We can check the number of blades rotated per second. With that, we can calculate the flow of the water or flow of the stream. And this is another method, positive displacement flow meters. These are the oval type of gears, right? Here the flow direction, chamber to entrap the fluid. This is a chamber to entrap the fluid. This is a chamber. This is chamber, these are the oval gears, and this is the flow direction. With that also, based on the rotations, RPMs, we can calculate the flow velocity, flow meter, flow velocity of a liquid. So this is another method, water flow meters that are permanently installed on the water pipelines. This is a rotometer. This is called rotometer. And this is how it's work. Due to the pressure buildup due to the water or liquid, this knob will be pushed up and down with this spring, so that the indicator will shows what will be the flow rate of a given liquid.
Just ensure that the cylinder is firmly secured. Now, please remove the plastic cover and additional parts from the cylinder. When attaching your regulator, align the locating pins on the regulator to the corresponding to attach your flow meter, align the connection with the regulator outlet and tighten accordingly. Next, connect the oxygen administration tube to the oxygen nipple on the flow meter. Open the cylinder valve slowly to release the flow of oxygen and set your desired flow as prescribed. To finish, firstly close the cylinder valve to stop the flow of oxygen and allow the regulator and flow meter to bleed out any remaining oxygen. Once finished, shut off the flow meter. Thank you for watching this demonstration. For more information, please visit.
These type of flow meters are used in oxygen cylinders, argon cylinders. So that will help to check the required flow of a gas. So here, this is also type of flow meter. From this branch, you can check what will be the airflow or gas flow, required gas flow from the particular liquid. And here you can check the pressures by these two manometers. This is a vortex meter. So let's see that video so that you can understand how it works.
These substances are transported and distributed in piping systems every single day. They can include solvents and chemicals, oil and gas, fluids in primary industry, or steam for energy transmission. The fluids flowing through pipes often have completely different properties. Consequently, different principles for their measurement are required. One method is flow measurement based on the vortex principle. In 16th century Italy, Leonardo da Vinci observed how vortices form in flowing water. Some 400 years later, Hungarian physicist Theodore Fontana described the physical laws that govern how these vortices take shape. Here's how this measurement method works. Inside each vortex flow meter, a black body is located in the middle of the pipe. This body is a kind of obstruction that disturbs the flow. Downstream from the black body is a mechanical sensor which can register the tiniest pressure differences in the flowing fluid. If the fluid is not flowing, no vortices form. As soon as the fluid starts to move and reaches a certain flow rate, vortices gradually appear downstream of the black body. These vortices are detached ultimately on either side of the black body. They are carried away by the flowing fluid. Zones of high or low pressure are appear downstream. This create a phenomenon that is known as the carbon vortex field. These differences in pressure exactly match the frequency of the passing vortices and are precisely registered by the mechanical sensor, shown here in slow motion. This sensor is unique because it's inherently so well balanced that plate-borne vibrations of up to 1 gauge, pressure surges, and temperature shocks have no effect whatsoever on the measurement. The distance between two consecutive vortices corresponds to a defined volume of fluid. Therefore, total flow can be calculated by counting the vortices that the higher the flow velocity, the higher the measured frequency of vortices. In some applications, velocity is too low for perceptible vortices to form. However, the velocity can be increased simply by installing a vortex meter that has a reduced cross section. This modification does not affect measuring accuracy. Functionality can be enhanced by incorporating optional temperature measurement into the sensor. A configuration like this, together with a built-in flow computer, can calculate temperature-dependent mass or energy flow. This feature is particularly important in industrial processes involving saturated steam or gases. Are the world's most robust and reliable, a lifelong calibration factor that have won several prestigious awards and widespread acclaim. For all applications, get the right solution. This Compressor, a single source supplier for measurement technology.
So these are water flow meters that are not permanently installed on water pipelines, such as ultrasonic flow meters. So where we can check the measurement from a particular distance, or we can check it online. So we don't need to reach on the particular point to get the measurement. The speed measurement. What tachometers and stroboscopes do and where they are used. Measure speed of a rotating object, revolutions per minute, RPM. Used for motors, fans, pulleys. Tachometers are direct contact. So it will be directly contact. Stroboscopes directly contact, not possible or not safe. So let's discuss one by one how to operate a tachometer. Here also a display there, and this is a wheel. When turn it on, bring the wheel in contact with the rotating body. We can put this wheel whether onto a tire or whatever the rotating body, and operate that unit. While it's in operation, we can measure the RPM on this display, and we can measure the readings, how the RPM it has. How to operate a stroboscope. Mark line and rotating object. Point this at an object. Change a flashing unit until marked line stop moving. Read RPM on display panel. So did you understand how it's work? So this is the pulley, rotating pulley, right? This is a rotating pulley, and it will rotate onto this direction. We will mark a line on rotating body. and we will direct from this stethoscope. We put a flashing light on to this area, this point, right? This will be a flashing light. It will be automatically on and off. On and off. So for particular minute, it will be maybe it is 100 times, 1,000 times, so 100 times. Number of times it will be on and off, flashing, right? While it is operating, this one also on and off, right? We change this frequency where this line is visible at all time. So this will be rotating, and while we changing this frequency at a particular frequency level, we can see this line is always visible at this point. With that, we can check, we can calculate, we can measure how much of frequency we used here. Say we put 100,000 on and off times per minute. So the RPM will be 100 RPM, rounds per minute, 1,000 RPM. So likewise, with this rate, we can check, calculate the rotation speed of a particular rotating body. So this was this is a photo taken by a video camera where this helicopter is rising from the landing point. It's rising up to move away from this area. So here you can't see that how these blades are rotating. The rotating is not seen. That is, the camera we used have a frequency. Say it is 1,000 frequencies per minute, and that frequencies matches with this blade speed. Here also it has 1,000 RPM, so both will be matches, right? That's why we can't see this blade rotation with this video camera.
This is an electronic stethoscope, or just postponed for short. It's simply a function, right? The pressures are regular, right? And that is adjustable. And now it's flashing at 3,600 flashes per minute. And I'm increasing the rate right now. I can either increase it or increase it. We'll increase that some small steps. Now, we're probably familiar with strobe, for example, strobe effect in the video clip. Strobe lights that are used at pointers. Actually, the strobe light was invented back in the 1930s, and it was used originally to investigate the motion of motors. The motor was not strobe light, you can look at it with different stuff. Show how that works. So then we use this motor, just this fan motor, without the blades on it. Instead of blades, there's this cardboard disc, which has a white ring painted on it. And once you think of this as a clock, turn it on. It's not a speed clock. It's probably too fast for you to see the hand. But when you're out with the stethoscope, you'll be able to see the hand. Let's take a look at that now. You can see the hand, actually you can see several images of the hand. Now what I do is make it appear like there's just one image of the hand, and there's one as clearly as possible. This is why we're going to look at that in a moment. And this is the frequency now in big steps. And down now to 3,200 passes per minute, now 3,100 passes per minute. Now notice that the line first appears to be going one way, and then passing by the other way. Let's see how that's happening. First of all, if I could adjust this so that the line seems to be stopped, it's still heavy. Look like that for the moment. It's still moving the first. Okay. If it was completely stopped, or appeared to be stopped, then what that would mean would be every time we start this once, line will be less than the hand. So this flashes, you see the line in a particular position. The next time this flashes, the distance from the line, the line is in exactly the same position. That's the only time you see it, so it looks like it's stopped. But if it appears to be going slowly forward like this, it means that the line is flashing a little bit too slowly. So let's suppose the line starts right here. Between flashes, it goes like that and a little bit more because this time it's flashing a little bit too slowly. Next time it goes around once, it puts the original phase and then a little bit more. But it appears to be slowly moving forward if this time it's flashing too slowly. Right?
So what are the precautions? Be careful when bringing the wheel of the tachometer in contact with the rotating body. Do not wear loose clothes while tracking measurements with tachometer because these are rotating bodies. If you have loose clothes, that will touch with this rotating body and maybe a physical damage to your body. Avoid taking measurements alone. You should have another person at there. Always consult the operation manual before use. Leak detectors. What does a leak detector do? Detects the location of leaks. Detects almost any leak because short distance access are not needed, high pressure not needed, sensitive to sound, filters background noises. Here we can see is we can detect there is a leak, right? We can detect it, but it's hard to measure how much of leak is there. Where is a leak detector used? For measuring compressed air leaks, refrigerant leak, but no leak detector will find every leak. There are a lot of maybe a lot of locations where the leaks happen, but it's hard to detect. How to operate a leak detector? Turn on and put on headphones. Move probe along pipelines. Mark locations where hissing sound is heard. We have to use headphones and a monitoring device where we can use to put along with the pipeline. When we hear hissing sound, so that will be probably a point where a leak is happening. Precautions. Dust or smoke should not come out of the pipe. Avoid measurement at places with high sound levels because the high sound level means the leakage is considerably higher. So there may be a hazard or health hazards here. Always consult operating manual. Lux meters. Lux meters are used to measure illuminations, that is light levels in offices, industrial plants, streets, all other workspace. The proper lighting is needed, especially in the office area. So we need to have a particular given lux level. So that will help to concentrate on the people for their works. Even in a library, study place, that The proper lighting systems help them to have to concentrate on their work. So it is better to have a lux meter to check the available lux in the surroundings. How to operate the lux meter? Consists of body, a photocell, and a readout display panel. Lux meters readings vary for different light sources. How it's used? Turn on the lux meter, place sensor where the light intensity is to be measured. Read illuminations levels on the displays. The lux meter also has a infrared sensor where we can see the amount of lux is available. This is the type of lux meter. Here the sensor is there so that we can measure the lux. It's given 276 lux level. So these are the type of monitoring equipment that we used in industrials, but there are a lot of other type of monitoring equipments as well. So this is just for your understanding how this monitoring equipment help in our day-to-day applications and industrial applications. This help to improve the productivity of our systems, avoid safety hazards. So preventive measurements, we can use this equipment to check. For example, for instance, air leakages, right? If it is a gas, flammable gas leakages, the catastrophic failure will be happening. To avoid these type of risky effects, we can use this type of equipments periodically check, right? In a pressurized container, pressurized cylinders, if you see the pressure drop, probably there is a leakage of from the tank. So these type of equipments help to have a good environment and a productive environment. Finally, it will help to reduce the energy use. I will give a small example. Can anyone tell what will be the advantage of having this monitoring equipment on this particular incident? I have a air compressor, small air compressor I have. It is around 150 bar maximum pressure is there. It has a pressure level. It's automatically stopped at 120 bars. And again, it's on when the pressure drops up to 80 bars. The range is 80 bar to 120 bar. Today morning, I check my compressor and got to know that the pressure was dropped up to 30 bar. For my requirement, I again on the compressor and it will be stopped at 120 bar and it is automatically stopped. But I went to another place to do some other work. When I came back after 2 hours later, the compressor was still running because pressure was dropped up to 80 and again it started to build up the pressure up to 120 bar. So in this incident, can anyone tell what is the problem of this compressor? Can anyone guess of this scenario and explain? The problem of this system is there's a air leakage. That's why it's really automatically the pressure will be dropped due to the air leakages, and if it's reduced up to 80 bars, the compressor will be automatically on, and it pressurizes up to 120 bars and stop. Again, due to this air leakage, the pressure drops again up to 80 bars, again motor on and compressor on. Likewise, this will be happening several times to make the pressure up to the required level. Due to this leakage, the motor will be continuously running. So that will be the wastage of energy. Where the motor is running continuously, periodically, that consume energy, additional energy. That's due to the leakage. Also, that will damage the motor as well. So motor lifetime will be reduced. So those are the disadvantage of having this type of air leakages. So if you see this air leakage or drop, so if you put a particular appliance or monitoring equipment there, so we can identify and rectify the failures. So we can check where the air leakages happen, whether it is on the nozzles or joints or on the pipeline systems. We can put this type of monitoring equipment to check where the leakages is happen and do the corrections on to rectify those issues. That will help to improve the productivity, reduce the energy wastage, and maximum use of the system. That's the end of the session. So if you have any problems, please raise so that we can discuss. If you don't have any, if you don't need to have clarify something, let me know. Okay, then Yashod, are you there? Or shall we wind up the session and do another lecture another day? How about tomorrow morning? Shall we do it tomorrow morning? Okay, then let's wind up the session today, and I'll send a message that where the next session is happening. Probably tomorrow we can do another session. We have now we have already done this monitoring equipment. We want